Now we will study two more topics. First is defining square root of a complex number. It's very simple. Okay. We take any complex number and we square it by the rules of multiplication. So if you do that, then your complex number will be x squared minus y squared plus I into 2xy. Okay. So if you now call this complex number as u plus iv, then you can define the square root of u plus iv as the complex number x plus I y. Okay, so someone says please find the square root of u plus iv. Then how will you proceed? You will look for those two numbers whose difference between whose squares is u, and the product of those two numbers when multiplied by 2 is v. Okay, so now let me take these examples. Let me take the second one, 3 minus 4i. What will happen if I square this complex number? I will get 9 minus 16 plus I into minus 24. Okay, so if I have the complex number minus 7 minus 24i, then the square root of minus 7 minus 24i will be, you can now say plus or minus 3 plus 4, sorry, not 3 plus 4, 3 minus 4. Okay, so it is always a trial and error method to search for those complex numbers or those two real numbers x and y, such that difference between their squares is your real part of the complex number and 2 times the product of real and imaginary parts is your imaginary part of the given complex number. Okay, then what do we mean by previously unsolvable quadratic equations? Those quadratic equations for which the discriminant was negative. Okay, but now we can easily solve such equations. Yes, so let's consider the following quadratic equation: x squared plus x plus 1 equal to 0. Here both a and b as well as c, all of them are equal to 1. So what will the roots be? Minus b plus or minus root of b squared minus 4ac upon 2a. So we have got minus 1 plus or minus negative 3's root upon 2. So we may write it as negative 1 upon 2 plus or minus I into root 3 by 2. So we have got two roots. Yes. See, the sum of roots formula, the product of roots, all of them are same. They do not change. When we solved MCQs on quadratic equations, whatever formulas we use, all of them will be applicable here. Okay. But now we are in a much better position to solve any quadratic equation because we have a definite answer to the question, what if the discriminant is negative? We just say root 3i, because root of 3 is basically root of minus 1 into 3. So root 3 as it is, root of minus 1 is I. The other speciality of this quadratic equation is as follows. If you take these two complex numbers, you note that both of them are complex conjugates of each other. If you cube them, you will get 1. So these are also often called as the complex cube roots of 1. I'll talk about it later, but as of now, please remember how to solve a quadratic equation provided the discriminant is negative. I think this is pretty simple.